Now, when I say it's really fancy, all it is like really at the core of the unit, it's just a timer.
Okay.
That's all it is. Then there's some software that's in there that can take the timing numbers. Sorry?
Well, hop over here. Then you don't just try to
Yeah. That's all right. And it takes those timing numbers and then turns it into other things. So really, we start by entering a couple different pieces of information. We want to let the unit know approximately how long the fasteners are within about a 1/4 inch.
Okay.
Because that's going to tell the unit where to start looking for the echo.
Yeah.
And that's basically what's happening is when we send a pulse down, the second that pulse goes, the stopwatch starts clicking over, the pulse runs to the end, hits the end of the fastener, some leaves, but most comes back.
Yeah.
When it gets the signal back, then it stops that timer. This happens millions of times a second.
Yeah.
So by telling it approximately how long it is, it knows where to look for the echo.
Yeah.
So the area of the fastener that's going to be under load, because this part of the fastener is going to be stretched, so it's going to have a different density. It's actually going to get more dense when it's under load, which means the wave is going to travel quicker through that part of the fastener than the unloaded parts.
Yeah.
Just understand that ultrasonic length is not going to relate to mechanical length. So
Yeah.
if you see that there's a difference, don't worry about it.
Yeah.
When we start with the unit, most of this stuff, do you guys ever use?
Never.
I mean, you haven't really used the unit.
Yeah.
What this is for is transferring the data from the unit to a computer. Yeah, you can actually download the software too.
Okay.
So we can show you how to access that. Then when you interface to the computer, you can just take these readings, plug them into a spreadsheet, and then generate reports as well.
Yeah, okay.
So that's a secondary thing that you can do. You guys have the two things that we're looking for. So this is your temperature probe. It will measure temperature in real time, multiple times per second, and it'll adjust.
Yeah.
So the GU is what's called an acoustic couplant. It's well, we can put this thing on the fastener. Microscopically, there's a world of gap.
Yeah.
Like, because of the surface and because of the transducer, the wave just won't carry into the fastener. That's what this does.
Yeah.
That's way more than enough.
I know.
Oh,
Okay.
Yeah. So on now, it's really important that your transducer is centered as much as possible. You don't want to have any rocking. If there's a ridge or what have you, you're not going to get good readings. You might be able to kind of fudge your way through if you play with a bunch of stuff. Once you get it on, you want to hit the auto set button. That's going to go through and scan the entire wavelength. It'll pull in and say, okay, yeah, we've got a good wave here.
Yeah.
And we just go enter. We hit, now again, when I hit enter, it dropped to the next cell automatically. We'll go through, take that, we hit enter, it drops to the next cell. Put a little bit of goo. So if we go to number 1 and we move into the to the mirror, like to the open cell, the B column, right now it's still showing basically 0.07 of a millimeter. If we go through,
So now that you have your reference stored and you go, then you're gonna start measuring your stretch.
yeah, we're going to pretend that we've tightened this
Yeah.
thing, but if you watch the display in real time, like as I'm tightening, that number's going up. So then we'd be able to record that. You don't hit the auto set on the loaded side of things. You would just hit enter. We go to number 2, go through and check, and then you make your adjustments as needed.
Yep.